Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 9 of a unit motion in a plane. So let's begin with today's class. In today's class we are going to discuss with the relative velocity. Now if you remember that we have already covered the relative velocity in one dimensions in unit number 3, which is a motion in a straight line. So let's just revise it very quickly, and now onwards we are going to discuss about the relative velocity in a plane. Basically it's a two dimensions relative velocity questions. Yes, so let's first revise quickly what is the relative motion. Yes, so let's begin. When we say the motion of a body with regard to another body, then the motion is called as the relative motion. So the corresponding velocity of this kind of motion is known as the relative velocity. Let's suppose that two objects are there. When two objects A and B are moving along a straight line, and the position of the particles A and B are the XA and XB respectively at any time t from the origin. Let's have a look that this is the origin, this is the position of particle A with respect to origin, and this is the position of particle B with respect to origin. Then the position of object A with respect to object B is can be written as XAB, which is equals to x of A minus x of B. And if we compare, or if we compare their velocities, let's say suppose this is VA and this is VB, then the velocity of an object B relative to the velocity of an object A can be calculated as VBA is equals to VB minus VA. If you remember this thing, then when we say that if two objects are moving in same direction, then we subtract their respective quantities. That means if velocity would be there, velocity would be subtracted. If acceleration would be there, acceleration would be subtracted, and the things would be like this. I hope those things are clear. Now XBA, which is equals to XB minus XA, and let's suppose the differentiate with respect to time, this is equals to VBA, which is VB minus VA. If this two are, let's say this is VB and this is VA, and angle between this is theta, then magnitude of relative velocity can be calculated based on this. This is VBA. I have put it into the mode, so I am interested in the magnitude only. VBA, which is equals to root of VA square plus VB square minus of 2 into VA into VB into cos theta. Now let's discuss certain the special cases based on this. When two bodies are moving in the same direction, that means let's say VA is in this direction, even VB is in this direction, that means theta between this two is the 0 degree, and when theta is 0 degree, cos 0 degree is equals to 1. So this is equals to VR, which should be VA minus VB. Yes, I hope is it clear? Is it? Now let's suppose that when two bodies are moving in the opposite directions, that means VA is in this direction, VB is in this direction, and the angle between this two is 180 degree. Then the relative velocity is equals to the sum of their velocity, which is 180 degree cos 180 is equals to minus of 1. Yes, it is the same thing that we have discussed previously in the unit 3 motion in a straight line in the sections of the relative velocity. Let's have a look another cases. Suppose we are considering two cars, one of the car A and another car B are moving parallel to each other with their velocities VA and VB respectively. If I need to find out the relative velocity, of A with respect to B, then VAB is equals to VA minus VB, as these two are moving in the same direction. You can see this. If these two are moving in the same direction, I am going to subtract their respective quantities. Okay, now look at this situation, that one of the car, it's in car A, and this is a car B. These two are moving in opposite direction to each other. This is moving in positive x, this is moving in negative x. So when I try to find the relative velocity of A with respect to B, I am just going to add their velocity. So VAB will be equal to VA plus VB, and the same way, on a same way, relative velocity of B with respect to A is VB plus VA. So the logic is, if two objects are moving on the same direction, you need to subtract it. If two objects are moving in the opposite direction, you need to add it. Yes. And let us suppose that two objects are there. They are moving mutually perpendicular, look like this. Then VAB or VBA, that means the relative velocity of A with respect to B or relative velocity of B with respect to A, then it can be calculated as under root of VA square plus VB square. And a situation is something like this. It's in VA. Let's suppose this is VB, and the angle between this is the theta. Then VAB can be calculated as under root of VA square plus VB square minus of 2 into VA into VB into cos theta. Yes. Is it clear? Is it clear? Is it done? So ready for the questions? Let's have a look. Suppose this is velocity of car A. This is the direction of velocity of car B. This VA is equals to 20 meter per second. This VB is equals to 60 meter per second. We have been asked that find VBA. It's a relative velocity of B with respect to A. I can see that these two objects are moving in the same direction, and when these two objects are moving in the same direction, I need to just subtract it. It's in VB minus of VA. So this will be equals to 60 minus of 20 will be a 40 I cap if required meter per second. This was the answer. I hope this is clear. Is it? Yes. Next question is that suppose car A is there, which is moving with 20 meter per second, and car B is there, which is moving with 60 meter per second. I need to find VBA. It's a relative velocity of B with respect to A. So for VBA or a magnitude of VBA, as these two objects are moving in opposite direction, VA and VB, these two objects are moving in opposite directions. So when these two are moving in opposite direction, I need to simply add it. It's a VB plus VA, which will give me an 60 plus 20, that would be equals to 80 meter per second. Is it clear? Is it clear? Okay, so can you do this? Are you sure? Are you sure? Let's look at the next question. Suppose it is a situation of, let's say, crossroads, something like this. And here one of the object is there, let's say object A, which is moving in this direction. That is VA is equals to, let's say, 20 meter per second. And another object is there, which is moving in this direction. Yes, this is Y. this is x, so it is moving in plus y. It's a plus j cap kind of situation. This is b, and this vb is equals to 40 meter per second. Please remember this diagram. Yes. Now what you require, find out first relative velocity of A with respect to B. Second, relative velocity of B with respect to A. This is what you require. And when I say I require a relative velocity, that means I require their magnitude as well as direction. Please mind well, it's an velocity, it's a vector quantity, and when I talk about the vector, I talk about the two dimensions. I'm talking about the magnitude as well as I'm talking about the direction. So what should be the to do when I need to find out, the relative velocities? So let's have a look. This was our situation, that my object A was moving in this direction, which is a 20 meter per second, and my object B was moving in this direction, which is 40 meter per second. And let's first find out relative velocity of A with respect to B. Relative velocity of A with respect to B, which is a VAB. That means I require VA minus of VB. Is it clear? Yes. So when I say I require a VA minus VB, can I write like this? It's a VA plus minus of VB. Is it clear? Yes. So if I redraw this structure, the situation would be, this is my vector A, or I can say it's a velocity of A, and this is velocity of B. But what I require minus of B. So to make this vector a minus of this, I need to just multiply this with minus 1. It's a minus of VB, which is 40 meter per second, and this is 20 meter per second. So if I redraw or rearrange this, the situation should be something like this. This is VA, this is minus of VB, and this V relative should be, as you can see, this is the angle between this two. It's an angle of 90 degrees. So this VR should be is equals to under root of VA square plus VB square. First we are talking about the magnitude. It's a 20 square plus 40 square. So 20 square, it's an 400, plus 40 square, it's a 1600, plus this is 2000. So if you just want to simplify this, it is 5 into 400. So this is 20 root of 5 meter per second. This is VR. That means we are talking about the velocity of A with respect to B. It's in magnitude. Now let's talk about the direction. You know this, that this is north, east, west and south. My one of the vector is at here, it's in VA, another vector is here, so the resultant must be at here. This is VAB. I'm not talking that they are bisector, no, they are not, but it is somewhere here. So what I can see is that velocity of A with respect to of A with respect to B is in south east direction. That's it. I hope those things are clear. So velocity of A with respect to B is in southeast direction. Is it clear? Is it? Great. So now let's work for the second question. This was the situation. This is A, this is B. What I require? Now I require that relative velocity of B with respect to A. This is my requirement. So it's a relative velocity of B with respect to A. That means what I require? I require VB minus of VA. That means ultimately what I get? It's a VB plus minus of VA. If I can find it, it would be our task would be a done. It's an VB minus of VA. So if I redraw the structure, I require a minus of VA. So this is velocity of B and this is the vector of minus of VA. So as I can see, the angle between this two is the 90 degree. So when I find out the magnitude of this, it's in VBA, which is equals to root of VB square plus VA square. Yes, this is under root of 20 square plus 40 square, which is 2000, and when I write 2000, it is 20 root 5, 400 into 5. It's a 20 root 5. So the magnitude wise it is the same. Even when I find out the relative velocity of A with respect to B, the magnitude was the same. Now let's talk about the direction. So if my one of the vector is here, another vector is here, then the resultant velocity must be over here. This is not a bisector. I am not even talking about it. But it must be in this direction. Now this is which direction? It's in, let's say, news. Yes, and this is northeast. So relative velocity of B with respect to A is in north west direction. Is it clear that relative velocity of B with respect to A is in northwest direction? It's in northwest. Is it clear up till now? Anything else? Any doubts? No? Okay, so shall I add something? To this question? Let's have a look. That in the previous question, of VBA, find angle of relative velocity, that means VBA, with VB. Now the situation was something like this, that this was minus of VA, this was plus VB, and VAB was in this direction. Now I am interested in this angle theta. So what I can do is that, let's say that this is minus of VA, this is vector B, it's in velocity of B, this would be the VAB, this is theta, even this will be a minus of VA. So if I observe this diagram very carefully, or shall I give the name? Shall I? Okay, let's say this is A, this is D, this is E. If I observe this triangle very carefully, this is 90 degree. So from this diagram what I can write, it's a tan theta should be is equals to VA divided by VB. Now velocity of A, what was it? Yes, it's a 20, and velocity of B, it's a 40. So this is 20 divided by 40, it's a 1 by 2, that is equals to 10 theta. Or I can write like this, that theta is equals to 10 inverse of half. Yes, this would be the answer. I hope these things are clear. Is it clear? Is it clear? Any doubts? Anything? Any doubts in this? No? Great. Let's move to the next question. Now suppose this is object A, which is moving in this direction. That means this is the horizontal line, and this is, let's say, 30 degree. This is velocity of an A, which is 20 meter per second, and here an object is there which is moving in this direction. It's a minus j cap, and it is moving with a speed of 10 meter per second. One more object, it's in C, which is moving in this direction, and velocity of C is 20 meter per second. Now what is your task? You need to find out first V A B, and we are at this point of time interested in the magnitude only. So we need to find out VAB. How should I do this? How should I do this? One of the approach will be that this is 20 cos 30 degree. This is 20 sin 30 degree. So VAB, what I want VA minus of VB. So my VA, or a velocity of vector A, can be written as, it's a 20 into cos 30, which is root 3 by 2 I cap, plus 20 into sin 30, it's a 1 by 2 into j cap. So 20 by 2, it's a 10 root 3 I cap, plus 20 by 2, it's a 10 j cap. This is VA. Velocity of B, which is 10 meter per second and moving in negative x direction, it's a minus of 10 j cap. Yes. Now what I want a VAB. I want a velocity of A with respect to B. So VAB can be given as, it's an VA minus of VB. So I know that there is an addition of I cap to I cap and j cap to j cap. So this is 10 root 3 I cap plus 10 j cap plus 10 j cap, which is 10 root 3 I cap plus 10 plus 10, it's a 20 j cap. This would be the final answer. And if you want the magnitude of the same, it's a square root of 10 root 3 whole square plus 20 whole square, and this would be the answer. Is it clear? Is it clear? So can you do this? Can you do this? Are you sure? Now, in the previous question, find VCB, velocity of C with respect to B. So according to the diagram, C was something like this, and moving in this direction with speed of 20 meter per second. B, it's a 10 meter per second. What I want a VCB. That means I am interested in this VC minus of VB. So VC, it is of 20 I cap, VB, that is of 10 or minus of 10 j cap. Yes. So that should be is equals to 20 I cap minus minus plus 10 j cap. If I find out the magnitude, it's in root of VCB, which is 20 square, it's in 400 plus 20 square, it's in 100. So that should be is equals to root of 500, and this is equals to 25 into 20, or what I can write is 100 into 5, it's a 10 root 5 meter per second. Yes, is it clear? One more question, one more. Let's have a look. In the previous question, find VCA. The previous question, find out the VCA. So how should I do this? What is A? What was it? It was something like this, that this is point A, this is 30 degree, and this would be 30, oh sorry, it was 20. The speed is 20, it's a 20 cos 30, and this is 20 sine 30. Yes, it's a 20 cos 30 and 20 sine 30. So vector A would be 20 cos 30 I cap plus 20 sine 30 j cap. When I solve this, it's a 20 multiplied by root 3 by 2 I cap plus 20 into half j cap. This would be 10 root 3 I cap plus 10 j cap. And velocity of C, it is in this VC is equals to 20 meter per second. So this VC is equals to 20 I cap. What I want to find out? I want to find out VCA. It's in velocity of C with respect to A. This is VC minus of VA, and this is equals to 20 I cap minus of 10 root 3 I cap minus of 10 j cap. This could be equals to 20 minus of 10 root 3 I cap minus 10 j cap. That's it. Yes, I hope now you will be able to solve this kind of questions. Yes, this is the very basic, these are the very basic questions of the relative velocity in 2D. I hope these things are clear to you. Is it clear? Great. Now let's look at the next question. Suppose the situation is something like this. This is X, this is Y. One of the particle is there which is moving in this direction VA with a speed of 10 meter per second. Another particle is there which is moving in this direction. This is VB, and it is moving in this direction. This angle is 30 degree, and even it is moving with the same speed. It's a 10 meter per second. What I need to find out? I need to find VAB, that means the relative velocity of A with respect to B. One of the approach, and probably the safest approach, is that I consider this as a VA, which is 10. So VA would be is equals to 10 I cap VB. So B is moving in this direction. The particle B is moving in this direction. This angle is 30 degree. So when I say this angle is 30 degree, it's an 10 cos 30 degree, and this is 10 sine 30 degree. So VB, it's an 10 into root 3 by 2 I cap plus 10 sine 30, it's an half j cap. So this is 5 root 3 I cap plus 5 j cap. I need to find out a VAB. So it would be an VAB will be equals to VA minus of VB, and I will find out the rest amount of thing. It's an VA and VB and something like this. Yes. So can we do this? Can you do this? It's an 10 I cap minus of 5 root 3 I cap minus of 5j. You can do the rest amount of thing. This is VAB. Now one more approach is, and which is very critical, that let's say, suppose let's derive it for a general term. This is velocity of A and this is velocity of B and this is angle theta. Yes. Now let's assume that the velocity of object A, is the V. Velocity of object is V. That means both are moving with the same speed. And I need to find out VAB. So what I am supposed to do is that this magnitude of VAB would be equals to root of V square plus V square minus of 2 into V into cos theta. If I solve this, it would be under root of 2V square minus of 2V square into cos theta. So this is equals to 2V square into bracket 1 minus cos theta, and which will be 2V square multiplied by 1 minus cos theta. It's a 2 sine square theta by 2. So this will be equals to 2 into 2, 4. If I take it out of the square root, it's a 2 multiplied by V square, it's a V multiplied by sine of theta by 2. This is the general relation to find out the relative velocity, but this can be used for VA is equals to VB is equals to V only. Yes, if your magnitudes are equal, then and then you can use it. So if you are using this relation, look at this. This is the one of the approach that we have already used, that I know. Now how can I do this? It's an VAB, which should be is equals to 2 into 10 into sine of 30 by 2, which is 2 into 10, it's a 20 into sine of 15 degree. Now one of the question is, sir, how should we calculate sine 15 degree? Any one of you know this? That sine 15 can be written as sine of alpha minus beta, which will be in sine alpha cos beta minus of cos alpha sine beta. Here in this case, my alpha, what is it? My alpha is 60 degree, 60, and beta is 45 degree. Now you know the value of both. You know the value of 60 as well as you know the value of 45, and the things can be done very easily from this. Basically it's a shortcut which will help us to save the time, and time saving is very important to us. Yes, I hope you can do this. Will you be able to do this? Are you sure? So let's look at the next question. The question is that one of the circle is there, and here particle A is there. It is the center of the circle. This is the radius R. A particle A is there which is moving in this direction VA with a speed of 10 meter per second. Here another particle is there, it's a particle B, and even it is moving in this direction with a same speed, it's a 10 meter per second. What I have been asked? I have been asked that find out VAB, it's a relative velocity of A with respect to B. This is what my requirement is all about. So look at this, both are having same direction, both are having same magnitude, I'm sorry, and the angle between these two vectors is of 90 degree. So when I find out magnitude of this VAB, it's a 2 multiplied by V multiplied by sine of theta by 2. It's a 2 multiplied by V, it's a 10 multiplied by sine of 90 by 2, and 90 by 2 will be a 45, so it's a 20 into sine of 45 degree. I'm interested in this. Yes, so this is 20 multiplied by sine 45, it's a 1 by root 2, which will be a 10 root 2 meter per second. That's it, you did it. Great job. I hope those things are clear. Is it clear? Yes. So this is relative velocity of A with respect to B. This is VAB. Is it clear? Is it? Great. Now let's move to the next question. Suppose a circular path is there. This is the center of the circle, and one of the particle, a particle A is here, and it is moving in this direction with speed V. Another particle is in this direction, which is moving in this direction with again speed V. And what we have been asked, let's have a look. It's an R. Yes, so what they have been asked is that find out average acceleration, of particle A and B. Now what should you do, and how could you do this? What I know, average acceleration, it's an average acceleration can be calculated as delta V by delta T. Now if you look at this, it's an delta V by delta T. Now how can I calculate delta V? Look at this, both the vectors are there, they are having the same magnitude, but the directions are opposite, so this two have been aligned by an angle of 180 degrees. So what I can do is, it's a 2v sine theta by 2 divided by delta t. Yes, so this is basically a subtraction. If I write this vector as a vector of A and this vector as a VB, so what I am supposed to do is VB minus of VA. So directly or indirectly, this is the relative velocity only. Yes, I hope you understand this stuff. Directly or indirectly, this is the relative velocity only. This is VB minus VA, and this is a subtraction, or this is the relative velocity of kind where I need to find out the subtraction of two vectors which are aligned by an angle theta, and both must be having a same magnitude. So what I can write, it's a 2 into V into sine of theta by 2. Yes, but when you are going to use this, please make sure that VA and VB are equal. So let's use this. It's a 2V sine theta by 2. This is 2 into V into This is sine 180 by 2, which is a sine 90 degree, divide by delta t. Now the thing is, how should I calculate the delta t? As you can see this, that A and B are at the two diametrically opposite point of a circle. So delta t can be written as pi r by v. Yes. So this is pi into r divided by v. So now sine 90, it's a 1. It's a 2 into v square divided by pi into r. This is the average acceleration. This would be the answer, 2v square by pi r. What was yours? Is it the same? Is it the same? Yes, great job. Well done. So, will you be able to solve this kind of question? Will you be able to solve this kind of question? Are you sure? Can it be done? Can it be done? Great. So, this is the simplest approach. This is the simplest approach to calculate the relative velocity when my object is moving in 2 dimensions. Yes, so let's wind it up this lecture over here only. Yes, and I request you guys to please revise the motion in a plane from very beginning. That means the projectile motion, vectors, projectile motion, then it's an horizontal projectile, and now it's a relative velocity. When we are going to move in the next class, we are going to discuss certain detailed and very depth applications of the relative velocity in 2D. Till then, bye bye, have a good day, take care.